Okay, we're back. It's lecture 22, 2017, Energy 102. And we're going over the Kerr Dam problem. Oh, and again, my apologies. It's called Assignment 3, but for this particular course, we're calling it Assignment 2. I will give you one more problem set before the semester's over for a total of 3.
Is it titled Assignment 2?
I will change this one. I've already changed this from the website to problem set 2. I'm just going to call the new one 3. There'll be 2 problem set 3s, but there'll only be 3 problem sets. Yeah, but here it is. This is the second problem set. So we're looking at Kerr Dam, and it's 200 feet tall. Like I just said, 3 turbines. It regulates Flathead Lake, turbine 1, turbine 2, turbine 3, and these turbines range from 50 to 87. Now, what we're also given in this problem is that its current, and sorry, I apologize about the typo there, its current rated maximum electrical production is 200 megawatts. So the sum of T1 plus T2 plus T3 equals 200 megawatts. And that seems about the right range, right? So 200 divided by 3 is 66, 67-ish, and it falls right in that range. Now, we're also given, it produces about 1 million megawatt hours per year. So energy per year equals 1 million, so 10 to the 6th megawatt hours. Okay. Now we're asked what the capacity is. So we're given that it's on average making about 200 megawatts. So let's just say it ran 24/7, 365 at 200 megawatts. Let's just see what that is. E rating equals, let's see, what is this? 200 times 10 to the 6th watts. Oh, but let's do it this way. Equals 2 times 10 squared megawatts. So again, all we're going to do here is energy equals power times time. So energy rating equals 200 megawatts times, well, how many hours in a year? 24 times 365. What's buzzed out of calculator? Yeah, 200 times 24 times 365. What'd you get? 8760. Yeah, multiply it by 200.
Yeah, you got it.
So buck 1.75 times 10 to the 6th equals 1.75 times 10 to the 6th megawatt hours. I should have put that in here. This is, hours per day. This is days per year. The days cancel, and we get megawatt hours. So the rated, so if it were running full tilt, full boogie, 24/7, 365, it would make this much. So the capacity equals ER over E. Well, oh, the other way around. We want the little one on the top. That's weird. A bit over 1 million megawatt hours per year. Oh, yeah, okay, yeah, okay, this is 1 million, never mind. So let's rewrite it like this, yeah, so the equals EY over ER, there we go. EY over ER, sorry I had to move up to the top, I just get it all on one page. You should not write it on the top, you should write it down here. Capacity equals EY over ER equals 1 times 10 to the 6th megawatt hours over 1.75 times 10 to the 6th megawatt hours equals, let's go back here, so 1 divided by 1.75 equals 57%. Yeah. 57%.
Annual capacity, or
It's just, yeah, you call it annual capacity. So you've taken the average over 1 year. And the reasonable guess here would be that the daily capacity in, say, the spring would be much greater when you're getting big flow, and it would be less the summer, yeah. Right, you could say what was the capacity factor in January, February, March. You do the same math, but you do it on a monthly basis rather than, we just did it over annual. What else?
I guess just on to...
Yeah, but just, work it out, put it in Excel, whatever you want to do.
On to problem 2, I mean, yeah, just go right to 2. I mean, they're all kind of, I got the first one wrong, so.
All right, well, you got it now. Okay, so we want to augment Kerr Dam with pumped storage. Yeah, nearby wind farm. Cool. We can capture water volume after turbine discharge equivalent to a 100 meter by 100 meter by 5 meter deep reservoir to use as pump storage. After pumping this volume back into the main reservoir every day, 50 meters of effective head, 4 hours per day are available as turbine generators efficiency. How much average power and how much energy is kilowatts potentially available for the pump storage? Okay, I'm going to just digest all that, take a little break, and be right back. Better be recording. So you just to back up, we are right at the finish line here. Kerr Dam, we're going to capture water. So we've got a volume of 50,000 cubic meters. We're going to pump it uphill 50 meters, and our turbine is 80% efficient. So I just hopped out to this sweet little website. It's also in the textbook, but the energy in that water is its density times gravity times how high we pumped it times how much we pumped it times the efficiency. You divide that by 3,600, because this is going to be in joules, I guess, megajoules. Divide by 3,600 to get the whole thing in watt hours.
Okay.
So we pop this in. I left off the units, but density is 1,000 kilograms per cubic meter. Gravity is 10 meters per second squared. The height we just said is 50 meters. The volume is 100 by 100 by 5, and the efficiency is 0.8. Then we divide that by 3,600, and we just ran that through Microsoft Excel. There it is. And we got 5,555,556 watt hours, which is, 5,556 kilowatt hours. And now if you want to get power equals energy over time. And we're only gonna run it for 4 hours, but it wants the average hour per day, so we're essentially burning 24 hours in 4 hours. So the average energy, so the power equals, I'll put a little bar over this. The average power equals 5,556 kilowatt hours over 24 hours. So this is energy power equals 5,556 divided by 24 kilowatts. Which seems a little high. What does it? Let's go back to our problem statement. Megawatts.
How much energy is co-op?
Oh, I see. Well, okay, so it's relatively modest. I mean, it's an additional 231 if we do this in, yeah, so we do this power, let's just do it, equals that divided by 1,000, and we'll put a couple decimals on there. This is in megawatts, and then let's just see, additional, or this is the capacity was 200 megawatts, right? And this is going to be additional equals dink divided by dink. I mean, it's just it's modest. It's not a heck of a lot. It's a if we put this in percentage, it's a 0.1%. So you've added. It's not a heck of a lot, but something's better than nothing. Yeah, that's it. That's it. Okay, I'll see you on Tuesday. We finished we finished wind. We reviewed problem set 2. I've seen summary 4 coming in. So at this point, really all we have left, we've got an exam. We have 2 more exams. On 7/8, there'll be an exam that I launch a week from today. I've seen summary 4 coming in. So really we have 2 exams, 1 more problem set, and 1 more summary. So there's 4 weeks left and 4 more things to do. 1 thing per week, just like we planned. Yeah. Well, it's all right. It's all right. At this point, I'm not going to penalize for late work. Just, get her done, submit something, and we'll move on.
Oh, yeah, and I checked, Sustainaganza is 11 to 4.